So a conventional type of this type of microscope will give you maybe one image back every 5 minutes or so, whereas we're getting back tens of images a second. And actually we're able to use that to either record something happening, so we can add, say, salt solution to steel and actually watch it corrode in real time to get a much better understanding in how metals are damaged, or any other material for that matter. Or we're able to kind of take an image, move, take an image, move, take an image, move, and actually build up huge images, maybe terapixel in size. And at those kind of resolutions, a millimetre-sized area that we could image, we could do that in maybe about 4 hours currently. We're hoping to get faster. But in terms of the actual size of the data that produces, that's about 4 football pitches worth of data if it's printed out at photo resolution.
We began developing this in 2003, but really it's ramped up since about 2009. That's where we discovered the key understandings which have allowed us to do as well as we do today.
It's kind of like a record player, but about 1,000,000 times smaller. You've got a really sharp stylus, which you can see on the screen there. And it's, rather than seeing the surface, you're feeling the surface. It's got a very sharp tip at the end, and it gives it a lateral resolution of about a nanometre or so. So we're actually able to see individual molecules on surfaces, such as DNA, or we're able to see the minutest kind of fractures or inclusion within steels from a reactor, for example. So we can look at all different types of samples, either in air or liquid, and we get videos back rather than images. It's kind of really counterintuitive, actually. So we've got it's almost like a fluid effect. So rather than kind of being in direct contact with the surface with this very sharp tip, it's almost surfing across the surface like it's lubricated. And that lets us do the equivalent of kind of years of normal AFM imaging, but in a matter of a day without wearing down the tip, so we don't actually lose any resolution throughout that time.
We've done a lot of work with EDF Energy to look at the boiler components which they have and are fatiguing due to the exposure to high temperatures and carbon dioxide environments. And they're very keen to know a lot more about the underlying physics and the underlying material science which cause these components to age and to degrade. And we're able to give them very, very high resolution maps which otherwise are impractical to collect. So that's an example of working with industry, but we're also working quite closely with genomics experts to start to create a newer, a faster method for producing genomic data at much lower costs and with greater sensitivity.